Hey, yes, we're live. Great. Wait, so this is why we're live. We are really happy to be here. Welcome to day 2 of the PX4 Developer Summit. Thanks to everyone for joining in. We had a great day yesterday. There was a lot of community-driven talks. Thank you everyone that joined Slack, that joined the chat room, joined social media and followed us. You guys are doing great. This is an awesome time to be here together with you. I want to thank the volunteers and staff. We did an awesome job yesterday. Please let know the community volunteers on chat that you're here. Let us know where you're from, where you're watching from. Send us your pictures on the hashtag that's here above, the PX4 Dev Summit hashtag. If you're here to watch the PX4 Developer Summit, you're in the right channel. I'm Ramon Roche. I'm the program manager for Drone Code. We have a great event today coming up. I want to say a few things, announcements for the day. We had awesome stats on day 1. We had around 400 average viewers yesterday on YouTube, Facebook, Twitter. We also had around 400 on Bilibili, which is the Chinese mirror. In total, around 800. That's awesome. Social media is blowing up. The hashtag. Thank you again. We had a couple hiccups on audio yesterday, same as today. We'll make sure we got those solved. Thank you for your response. Thank you for the feedback. Let us know. We're here. We're listening. There's going to be a few additions today. Today we're going to have polls on Slack during the live stream. When we're switching from speaker to speaker, we're gonna throw a few polls on Slack, so make sure you're joined Slack. There's going to be a few community volunteers sharing the links on the stream. There's going to be also ratings, so go to SCAD, the event management platform. You can also rate the sessions from yesterday. You can also do that from the sessions today. Please do so. It's gonna help the speakers, it's gonna help us organize a better event in the future. Let's see what we got next. The live recordings, thank you for asking for those. There's going to be available 2-3 days after this ends. Our video processing team is really busy right now putting together everything you're seeing on screen today. So give us a few days before we upload the end products for those. If you're on Slack, please let us know. Share your LinkedIn profiles, share your social media, share pictures. If you're looking for a job, jump on Slack. Say hi. If you're a company trying to recruit PX4 developers, jump on our Slack, post your LinkedIn post, post your careers pages. Let's try to make this the best event possible we can. And lastly, there's going to be not so secret after party. That's going to happen 3 to 5 p.m. Pacific. But here's the catch. That's only going to be on Slack. There's going to be a link shared in there. Please make sure you go to Slack and get an invite to that. It's not going to be shared on YouTube. It's not going to be streamed to Facebook or Twitter, only on Slack. So make sure you go back to Slack, reach out to the community volunteers and get an invite. Having said that, I think it's time we introduce our speakers for today. The first speakers. Let's see what we got next. So looks like we got Pixhawk community-driven open standards for drones. And we got 5 speakers. We got Peter from Netherlands, Alex calling from Salt Lake City, US, Michael from Zurich, Switzerland, Lorenz also calling from Zurich, Nuno from Portugal, and we're starting the day off with a great panel. I look forward for this session. Guys, thank you again for being here. Don't go anywhere. I'll be back after this session ends, and thank you again for being here. Stand by while I connect you. Welcome back to the PX4 Developer Summit. My name is Ramon Roche. I'm the host for today. I present you the Pixhawk panel, Pixhawk Community-Driven Open Standards for Drones. The Pixhawk Open Standards provides related standard available hardware specification and guidelines for drone system development. The Pixhawk Special Interest Group is a network of companies that are innovators and maintainers of the Pixhawk reference standard. I'm joined today with the lead for that special interest group. This group meets every Tuesday. We've been meeting for the last couple of months, tremendous work for Pixhawk. I am really excited for this talk, and without further ado, I introduce you to the panel.
Hi, everybody. So finally, we're on. Thank you for the introduction, Ramon. I will be quickly introducing the background of each panelist, because our goal here is to have a really hands-on live discussion. This is not pre-recorded. We did not prepare any specific points to present. So we have here Nuno Marques. Nuno has worked in the last month specifically on the high-level CAN and onboard messaging, and I have a lot of questions for him, why that's important, how that's useful. We have Peter van der Perk from NXP. He is deeply familiar with the transport layer on CAN. NXP is the leading hardware company in the automotive space, and they have lots of experience with, for example, CAN there and safety. We have Alex, who joins us. Alex is running his own electronics company, and with that has looked very deeply into smart batteries and what it takes to really take this ecosystem to the next level. And finally, we have Michael. Michael has been the product manager of SkyNode, which is a very integrated avionics solution, and is also very deeply involved in the standardization efforts around the Pixhawk standard evolution. So the first topic that we'd like to dive into on this panel is onboard avionics and how we build networks on board. A lot of you who are familiar with drones will know that there's this inheritance from hobby parts, and so the interfaces so far have been extremely minimal, for example, with PWM. And so the first question to you, Nuno, would be like, I can connect motor controllers and servos and everything right now. Like, why do I need something else? Why do I need a standard?
Yeah, so we inherited most of the best of its applications with the usage of PWM, I2C, SPI protocols, for the peripheral connection in PX4. We mostly use PWM for ESCs, for server control, I2C and SPI for sensor data collection. But although these are functional, these protocols have known problems regarding reliability, right? So there are some specifics to the technology that make them probably not suited for safety critical systems that require a much more robust layering. And that layering is not just applied to communication between central control and monitoring units, which basically connects to the different peripherals or avionic components, but also for us a redundant distributed avionics system, as you talked about. So besides that, there's the need for that master on those buses removes the ability of having a distributed avionics system which is capable of working with a central unit, or it's capable of working, but without that central unit that defines addresses, that defines data rates, etc. And that's why the usage of CAN on avionics systems became, I would say, much more relevant, as CAN brings this peer-to-peer network capability with no need for a master, right?
Okay, but that's great, but there are already CAN parts, a lot of them. Even DJI is using CAN. So why are you working on a message standard for that?
Yeah, so if we consider that each vendor actually defines their own CAN protocol, even if they use the same physical protocol as CAN 2.0b or CAN-FD, if they use their or they build up their own protocol stack and specification, that will basically mean that for an interoperable component that we're trying to achieve, right? Um, hardware vendors and industry stakeholders basically consuming that same hardware will have problems in actually having their components or their hardware actually compatible with the different systems. So having this standard actually assures that we can guarantee that interoperability, and at the same time, the vendors and the hardware manufacturers are also making sure they are compliant with a specific set of rules and requirements, and they know also that their product is also plug and play.
Okay, so essentially the key takeaway is with that message standard, I can just connect, I don't know, a servo or motor controller to my commercial drone, and it will just work, no software changes.
Yes, exactly.
Okay, very cool. So one of the things that I find personally a bit confusing, and I'm sure a lot of people in the audience will have similar questions, is like, you know, what we already have UAV CAN V0. Now we're moving to UAV CAN V1 as part of that proposal. So how is that related? Isn't UAV CAN already defining what we're doing? So I'm confused there. Peter, maybe you can help me there.
Yeah, so there were multiple reasons why Pavel, the designer, and the UAV CAN team decided to go for V1. But it's mainly because they wanted to move forward to a one good generic system, but also support for CAN-FD as well. My apologies, I'm hearing a lot of noise. Yes, we're back again. With the lessons learned from Z0, the designers from UAV CAN decided to come with a clean slate and designed a new protocol that's simpler and also is useful for safety critical applications. So they want to support redundancy, so that's inside this protocol. And yeah, keep it as simple as possible, I think.
Okay, so essentially what you're saying is that on the protocol level, this is a really solid base to build on, but it's not specifying everything up to the sort of full implementation messages, and that's essentially how the DS15 standard comes in.
Yes, so when you look at the transport layers, we have our CAN bus, which just has basic frames, and UAV CAN to send big frames on CAN bus, and you don't have to worry about the framing of those messages. But here is kind of where UAV CAN stops. So the interoperability between let's say a motor and an FMU is not there. And the main goal is that if someone implements such a motor controller, they can follow the DS15 rules and have a easy plug and play system. Furthermore, as a flight management unit, we know what we expect from those components, and we have an interface where we can leverage that to, for instance, include a bootloader or have a mechanism to easily set up those components.
Okay, so it's pretty much like having USB, of course not literally, but equivalent. Like I can just connect the device and it'll work.
Yeah, that's the main goal of it. The main goal is having a plug and play experience and while still be able to go deeper if you really want to. But also for the implementer, there has to be clear rules on what your device has to support. So from both sides, you can integrate to a nice, tightly good product.
Yeah, that makes a lot of sense. So if I'm interested to contribute there, and if I'm interested to make my device compatible, or if I just generally care about this, like how do I engage Nuno? Nuno, you're muted.
Sorry. Okay. Can you hear me? So we have the UEFI CAN and CAN standardization coordination call that happens on bi-weekly on Tuesdays at 4 p.m. UTC. You can check the DroneCode calendar and add that event to your calendar as well. So basically, that standardization or coordination call is mostly used to foster the coordination and collaboration among the adopters and also the stakeholders of the unmanned avionics industry. And those might include, but they're not limited to, of course, the hardware manufacturers and vendors, and also unmanned aviation leading companies that use specific avionics components that leverage CAN or UAV CAN. And mostly what happens on those calls as a specific goal, we try to discuss and organize the efforts around writing and improving the SO15 CAN drone standard. And it involves some open discussions over the specific matters of the standard. Also reviewing what was the work done on the past couple of weeks and the added and updated components, verify if they make sense or not. And of course, also define the goals for the course of work on the next couple of weeks. So we can see it like a Scrum, a daily Scrum call, but like happen bi-weekly, adding also the blocker removing, if we can say so. Can you want to hear me?
Yes.
Yep.
Okay.
Yeah, cool. So Ramon, maybe you can share the links with the audience in the chat while we're talking, so people can engage. Otherwise, I can follow up in the chat later after this as well.
Just so you know, links are in the chat already.
Oh, perfect. So now that brings us to the next topic. So I already mentioned that Alex has particular experience with batteries. So, I mean, I've been using LiPo batteries for the past 10 years on sort of development systems, R&D systems. Like, why do we need to change that? Why do we need to change to a different approach of using batteries?
Yeah, I think for the Pixhawk hardware ecosystem to really evolve, we need smart batteries are kind of that last key thing to bring the safety and reliability up to the next level. Hyon from Uvify gave a good talk yesterday on the technical background on how smart batteries operate, but ultimately it's you can get the full capacity out of the pack safely without having to worry about completely running out too early, and so you can fly your drones longer and safer with smart batteries. So it's kind of the goal of the smart battery standard.
Okay, so how is the standard, in what state is it? How is it being developed? What are the next concrete steps for smart batteries?
Yeah, so far we've got we've defined the connector. We've got the connector, the pinout defined. We've got the the messaging set defined, the communication interface that's going to be on the CAN bus with UAV CAN B1. And as part of that UAV CAN standard, they were just discussing, we've defined the battery message set that all smart batteries that meet the Pixhawk standard will abide by. So being on the CAN bus and using UAV CAN will allow multiple batteries in parallel to be used much easier than just using SM bus. That was one main driver there. The next steps are, defining that mechanical interface and latching. That's probably the next big hurdle. Otherwise, most of the electrical and protocol is it's in place at the moment.
That's super cool. When do you expect from the adopting companies to see the first products on the market?
So I'm partnered with Holybro at the moment to bring the first Pixhawk smart battery to the market. So that should be sometime this year. You should see that on the market, and that'll be a 99.9 watt hour 6S pack, something you can carry on a plane. And yeah, so it's pretty exciting.
I think it is. I've met people who were essentially saying like, oh, this open source flight control work is really great and we're really happy with it. But as long as our end users have to use batteries that have leads and that have to be actually, dialed in on a charger, we can't sell that to our end users. It needs to be something that just gets stuck into a charger and that never gets deep discharged. And so I think that's as important as the radio link. Very, very cool. So the natural evolution, we've talked about the network, we've talked about UAV CAN as a transport, V1. We've talked about the message set for that as part of the DS15 standard. That naturally takes us to a part that is already in pretty good shape already, which is the flight controller itself, Pixhawk. And the fact that we've open sourced the hardware design 2013, 14, so already 6 years ago, led to a lot of compatible designs because people were mostly happy with it and didn't change too much, and so it just worked. But over the time, there was more discretion, and so today we have, 10, 15 different types of flight controller designs. They're all Pixhawk derived, but they're a little bit different, and sometimes the hardware vendors are relatively small companies and they struggle to maintain software. So that is obviously the segue, Michael, to the question to you, which is why 7 years after the first Pixhawk, do we need to standardize this? Why do we need standards for flight controllers and flight controller interfaces?
So as you already mentioned, there have been various flight controller designs over the years. And some of them, I would say, were more successful to work together with the software. And there have been issues from a sensor perspective, from a power supply perspective, or just the support from an overall community effort on these hardware designs. Now, standardizing an interface and the interface between software and hardware in that case really means that there is a clearly defined standard on how I can build a flight controller that is fully supported by the software side. Both entities know what they will encounter, and it is a seamless transition in that case. This just gives confidence for an end user that he can buy a product that is, he also knows that PX4 will run nicely on that platform.
Okay, that sounds fairly important. What does that mean for future upgrades? So we know there are always new processors. There are new processors coming from NXP with automotive safety features. How does this one standard help us in that regard?
Yes, so currently integrating a flight controller in a specific vehicle typically means also integrating against an interface that is defined by the manufacturer or vendor. for a commercial or industrial vehicle, this often requires to design a carrier PCB that then interfaces to the flight controller. Introducing a standard like the Pixhawk Autopilot bus is a way to completely standardize that and open it up to the market to develop a flight controller, and that is then also future compatible to an aircraft that follows the same interface. The standard has a pinout, it defines the connector on it, it has a mechanical layout, both in size and how it's mounted and where the connectors are placed. So if a drone OEM decides to integrate against that standard, it's not just compatible with the current flight controller design that is on the market, but it also is compatible with future designs that are coming later on with better compute, different designs, or other innovations that we will see in the industry just happening naturally by like other companies growing into the market by doing so.
Okay, that sounds pretty important for this industry to scale. Good. So how, if I want to use that flight controller because I want to create my own baseboard, or I want to maybe create my own flight controller, how do I engage?
So there is like pixhawk.org as a central point of reference where we publish also the documentation for all these standards, and you can find the latest releases that are already finished or complete. Then there is a bi-weekly call every second Tuesday where you can engage with the community where we discuss those topics. On those calls, part is the flight control designs like FMV, FX, and all these other generations that belong to it. We discuss the Pixhawk Autopilot that's there. But then there are also other standards like the Pixhawk payload bus or the Pixhawk smart battery that were also part of those discussions. So please join there and provide your feedback so you can have an influence on what we actually standardize and how the interface will look like in the end.
Very good. So, okay. I think we've covered a lot of ground. So those were, I think, my main questions. Now, I would really love to turn to the audience and see what questions are coming up. So I believe that there's one, or rather two topics that I quickly would like to cover that we haven't touched. So one is, we haven't really specifically talked about it, but part of the Pixhawk standard series is also a payload bus, and that is defining the interface to a gimbal or camera, or both. And it's using Mavlink for communication, it has Ethernet, it has USB, and it's something that you should also check out if you're interested in the standards. We're not discussing it to full depth today because we have different people on the panel. But it's something that is also well specified and where you will find drafts and where there is a bi-weekly discussion in the working group. Now, the other topic that was already asked in the audience, and please write more questions into the chat, was unmanned traffic management, UTM integration. And what are we doing there? So two things. Number one, there are a number of standardization efforts and bodies already in the space. There is also a inter-unmanned system traffic management open source project, inter-USS, part of the Linux Foundation. You can check that out. And we're implementing that, of course, as a community that's focused around the flight controller kernel. We are not necessarily driving our own airspace standards. So we're working with the existing bodies. We're really close there. We did an integration with AirMap, with PX4 and Q ground control about 2 or 3 years ago. You can, I'm sure, find the announcement online. This is something that you can also explore, and of course we're more than happy to welcome other UTM providers with an integration with Q ground control in our community. So very active there. We're not driving it ourselves though, because there are already great efforts underway. So let's see what came in terms of questions. So one question is, how does Pixhawk roadmap to compare to SkyNode? So It's really important to tell this apart. SkyNode is a product of a company. So from a PX4 perspective, it's just one of the products that is using the standard. In terms of standardization, we're looking at all the different stakeholders, all the different companies that participate. So there's Modal AI, there are companies like Holybro, CUV. There are other vendors who might not have engaged yet in the standardization effort, but who are super welcome to. There are end users like FreeFly, for example, that are using these standards, or Quantum Systems or others. And the goal of the Autopilot standard is to create a common base in terms of mechanical and electrical interfaces for these different parts and companies to work together. And then individual products use it and are compliant. And so you know that when a product uses the standard, that you get certain levels of interoperability, the same way as you know that if a product supports Wi-Fi or Bluetooth or USB, that certain things will work. And that's exactly the goal here. Let me see if there are more questions. Payload bus for RGB cameras only? No, the payload bus is super general purpose. You can connect a LiDAR, you can connect thermal cameras, anything. By default, we have a pretty well worked out set of camera standards, including for IR cameras, but that's being continuously expanded, so it's not limited to it. Let's see, more questions. 200 people there. No questions on standards. Any thoughts on working with parachute recovery system companies? Yes, absolutely. I mean, by all means, we're looking very heavily now in architecting software, hardware for safety. And that's part of the standardization effort. So parachutes are, of course, an important part of that solution. And so we're more than happy to collaborate on that.
Hey, Lorenz, Remote here. I have a question from the audience.
Yes.
Why reinvent the wheel with standards when the industry got plenty of standards already? Avionics, automotive, IoT, UGV, etc. Why not just pick one?
That's a good question, because everybody is trying, the old story is you have 13 standards, then you try to do one standard to unite them all, and then after that you have 14 standards. We're very well aware, but what you need to know is that we've done this Pixhawk standardization in the beginning since 2008, but really where the whole drone industry adopted it around 2013 with Pixhawk 1. And so that is a well-established thing. Google Pixhawk, see how many different models are out there. They're all using the same system architecture. They're all more or less software compatible. And that has already set a standard in this industry that a lot of people are implicitly relying on. The same way as the IBM PC set standards like the ISA or PCI bus for the PC industry. And so we're already there. We've already done it. And we've done it because all the aviation standards that are out there, they are targeting pretty high, I wouldn't say high end, I would say large, very regulated systems. And it starts with things like that every of these standard document copies is like $500. So if you're a smaller drone company, and you want to implement, I don't know, an aviation system, you end up easily spending $20,000 on PDFs. And so that's a non-starter already. So our standards are not just standards, they're also open, they're free. You can just download them. That's one big topic. And then the other topic is they're compact, they're easy to implement, they're small. And again, we're not starting out of nowhere. We're taking all the legacy, all the history of Pixhawk, and we're just formalizing what everybody is using already.
Great, thank you, Lorenz. So I'm going to give you one last question, and then I need to let you go because we have another speaker queued up. Last question is there going to be a specific organization to take care of the standards?
So they're all, the standards are all part of the Pixar working group. That is a project of the Drone Code Foundation. So part of what we're presenting here, part of this Dev Summit. And so we do already have a nonprofit organization that is already very familiar with standardization efforts, is backed by the Linux Foundation. So we have also the professional structure around it. And yeah, that's how we're driving it.
Excellent. Thank you, guys. Thank you for your time. Hey, folks. Welcome back to the Pixar Developer Summit. Glad all your issues are gone. This was just the panel. Thank you, panelists. This was really awesome. I want to thank them for their time and their awesome contributions they're making to the open source community. Pixhawk standards. Check out their website. We just linked it on the chat room on Slack and also on YouTube and Facebook, Twitter.